All right. So yesterday was an introduction to quadratics. Today is also an introduction to quadratics, but we're going to be, like I said, taking some more technical notes today on this. So we're just going to call this Intro to Quadratics. And let's see, what is today? The 18th. All right. So we saw yesterday a bunch of like y equals x squared. We saw y equals ax squared. We saw y equals ax squared plus c. We saw y equals ax squared plus bx. We saw multiple different forms of quadratics yesterday, but there is a chance we got some right here. I mean, there's some right here. Okay. So, and it's a pencil as well. What it sounds like. Those ones aren't yet sharpened. I think that one might be though. All right, cool. So we can actually put together all of that ax squared, bx, and c into the same equation. So the standard form of a quadratic equation is y equals ax squared plus bx plus c. All right. So y equals ax squared plus bx plus c. What's up? Yeah, I got one right. All right. So then, as long as the highest exponent is 2, it's a quadratic, and we learned that back in the previous unit. And it says when graphed, a quadratic equation creates a U-shaped curve called a. We talked about this yesterday. Does anybody remember the word? What do we call that U-shaped graph that we saw yesterday? Yeah, it's a parabola. Yep. So it's called a parabola. So the shape of the graph is called a parabola. And then there are basically 2 types of parabolas. Now it says to use your graphing calculator, but we don't use graphing calculators because we don't really have a class set of graphing calculators. Actually, what I'll do then is, so I'm just going to cross all this off, and it's just going to say sketch the following, because we don't have access to a graphing calculator, but I've got one here, so I can show you what this looks like. So just head in here and let's see, we need x squared plus 2x minus 5. And we'll go ahead and take a look at this graph here. All right. So we can sketch this graph. And again, this is not going to be like a super technical thing. This is us just kind of saying, all right, this is about what the graph looks like. We're not going into detailed graphing today because, well, we'll get into that later. And we're not going to be using graphing calculators for that. We're just going to be using like a table of values and things that we know how to use to put graphs on a coordinate grid. So the first one here, we have y equals x squared plus 2x minus 5. And the second one says y equals negative x squared plus 3x plus 7. So I'm going to go ahead and drop that one in as well. Let's see. So negative x squared plus 3x plus 7. All right. So draws, and it's gonna, the top of it is a little bit out of picture there, but again, this is just a very approximate rough sketch. So this one looks, about like that. We don't need to be super technical or detailed about this right now. All right. Now, yesterday, we also talked about a few different things about our parabolas. We talked about a thing called a vertex, and the vertex was the point that was in the middle of the graph. It was either at the top or the bottom. So on the first one, it would be down here. That would be our vertex down there. And on the second one, the vertex would be up here. The other thing that was mentioned was something called the axis of symmetry, and that was kind of that imaginary vertical line that splits the graph into two mirrored halves. And so the axis of symmetry is always vertical through the vertex. So it's just kind of, we can always do this little like dotted line here just to show it's not actually part of the graph, but that is that imaginary line that cuts the graph into two mirrored halves. If you folded it together at that point, the two halves of that graph would like match onto one another. And so for the second one, it's just this dotted, we'll just make a dotted line straight through there. So we've got the vertex is the point, and the axis of symmetry is the dotted line. Now, yesterday, we also saw the value of A. That first page that we looked at yesterday with our value of A, does anybody remember what A controlled when we were sliding it around? What did A do when we were moving it on that graph yesterday? What's up? You need to move it up? So what did A do in that graph yesterday? Justin? Yeah, it talked about the width of it. So it definitely controlled the width, whether it was a narrow graph or a wide graph. What else did it control? Like positive or negative? Like if A was positive or if A was negative. Does anybody remember about that? How did the graph look if those two things were different? Killian? Yeah, facing up like a regular U or an upside down U. So it controlled the width of the graph, like Justin said, and it also controlled whether it faced up or down based on whether A was a positive or negative. So we're going to say if A is positive, then the graph opens up like a smile. And then the opposite of that obviously would be if A is negative, then the parabola opens down like a frown. All right. Next, we're going to just talk about the axis of symmetry. And so the axis of symmetry, we've already mentioned this before. It's that, imaginary vertical line. The definition we're going to write for this is the vertical line that divides the parabola into two equal parts. So axis of symmetry is the vertical line that divides the parabola into two equal parts. Go ahead and get that written down, and then there's actually a formula to figure out the number or the value of that axis of symmetry. And yesterday we were able to locate the axis of symmetry based on the graphs that we saw, right? Especially when we were talking about that very last page with the value of B, where it was moving the graph left or right a little bit. So we are going to actually have a way to calculate this without using a graph. So the formula for the axis of symmetry, the axis of symmetry is always an X value. It's just X. It's X equals like a positive number or maybe a negative number, but it's always just X equals. And so the formula is this: X equals whatever B is, we're going to take the opposite. So it's the opposite of B. So if B is a positive, then that number becomes negative. If B is a negative number, this number becomes positive. The opposite of B divided by 2 times whatever the value of A is. So X, the axis of symmetry, is equal to the opposite of B divided by 2 times A. And we're going to do a lot with the axis of symmetry today. And then we can use the axis of symmetry to figure out what the vertex is. Because if we go back to these graphs here real quick, I'll move back down in just a second. Because the axis of symmetry is always with the vertex, it is going to be the same as the X coordinate for the vertex here and here. Any axis of symmetry will always be equal to the X value of the vertex. And so we can use that axis of symmetry value to figure out what the vertex is. And the vertex is the turning point of a parabola. It's the point in the middle, the center point. The last little bit of setup work here, we're going to be talking about the two words that we use for whether or not the vertex is the lowest point or the highest point. We talked about these yesterday. It was part of the, I think it was on each page. So when the vertex is the lowest point, what did we call that? Yeah, it was a minimum. So when the vertex is the lowest point, meaning if it's facing upwards, right? If it's a regular U, which means that A is positive, the lowest point, it's called a minimum. And I'm just going to make a quick note off to the side here. This means that A is positive. If there is a minimum point, the value of A is positive because it's an upward U, which means it goes all the way down to the bottom and then back up. So when the vertex is has a highest point, or is the highest point, what would we call that? We saw this yesterday as well. Yeah, it's the maximum point. And if it's a maximum point, that means it's an upside down parabola, which means that A is negative. So if you want to know if the vertex is a maximum or a minimum, look at the value of A. All right. So the rest of the notes are going to be calculating things. We're going to be figuring out what the axis of symmetry is. We're going to be figuring out what the vertex is. And we're going to make a quick sketch of the graph, which means we need to know whether that graph is going to be opening up or down. So first thing we're going to do on every single one of these is we're going to identify the value of A, B, and C. So A is the number that goes with x squared. If there isn't a number in front of x squared, what does that mean that A is equal to? What is it? 1, exactly. So we're going to say A equals 1. I'm just going to write that underneath where it says examples. The value of B is the value that is with x. So what does B equal? Just regular x, not x squared. 8. So B equals 8. C is always the number by itself. 15. All right, so we have A, B, and C. And the value of A is positive. So does this open up or does it open down? It opens up. So it's just a regular U. So I'm going to say opens up. So we're just setting up, getting some information because when we sketch this, we're going to need to know that this is an upward facing parabola, a regular U shape. All right, now we have to figure out the axis of symmetry. And the axis of symmetry is going to be found by using the formula for that, which is this x equals the opposite of b divided by 2 times a. So we're going to say x is equal to, if b is 8, what's the opposite of b? Negative 8. And we're going to divide that by 2 times a, which would be 2 times 1, which is just 2. What does negative 8 divided by 2 equal? Negative 4. So our axis of symmetry is x equals negative 4. So that line where it says axis of symmetry, you're going to write x equals negative 4. Now the vertex is the point that's the middle of the graph. The x-coordinate of the vertex is always equal to the axis of symmetry, negative 4. So no matter what, the x value of our vertex is going to be negative 4 here. What we need to figure out is what is the y-coordinate of that vertex. Does anybody have any ideas on how to figure that out? How could we find out the y value of the vertex if x is negative 4? Billion? What's that? Let's see, the value of a doesn't really tell us where the vertex is. It tells us if the vertex is a minimum or a maximum. In this case, it is a minimum. And it tells us kind of the width of the graph, but it doesn't actually tell us where the vertex is. Alicia? Exactly it. So remember when back earlier in the year where we had equations or we had functions, and it said, figure out the number if the variable equals this, plug the variable in and then solve. That's what we're doing. We're taking the value of x, -4, and we're substituting it in to this equation here, because what we want is y. We have an x value, -4, here and here. We want the y value for when x is -4, and this equation here says y equals. So we're going to take this value of x and plug it into this equation. And this is where you might want to calculate. So we're going to say y equals. And then anytime you square a number on a calculator, how should that be written on the calculator? Somebody tell me. I've mentioned this a few times. Alicia? In parentheses. Yes, especially if that number is a negative. So -4 squared, and then plus 8 times -4 plus 15. Now you can type that in exactly as it is right here on your calculator. But if you don't put this -4 in parentheses, it will not give you the right answer. -4 squared, that's 16. 8 times -4 is -32, and then plus 15. So that should be -1, right? All right. So y equals -1. And so right down here, we have x equals -4, y equals -1. So we've got our x and y right here. So then with our vertex, we just need to fill in that -1 for y. And that's where the vertex is. -4, -1. And then we're going to do a very basic sketch. Again, we don't even need to put numbers for our x-axis or our y-axis. We just needed to do something like this. Just create a quick grid, about like that. And our axis of symmetry is at -4. So as long as we have our axis of symmetry in the negatives, which will be over here, so that looks like, I don't know, maybe that's -4. Again, we're not doing numbers on our number lines here. And so if this is -4, then our vertex is at -1, so just a little bit down from there. So there's our vertex, right about there. And then it's going to open upward. So it'll look about something like that. So just a very rough sketch, almost no detail whatsoever, just to get an idea about what that graph looks like. So we know it opens up, we know where the axis of symmetry is, we know where the vertex is, that's about it. Every other problem on here is exactly like this one that we just did. So let's go to the second page. Any questions so far? Second problem, here we go. We got y equals -x squared plus 10x minus 23. So once again, we need a, b, and c. So what does a equal on this one? -1, good. -x squared is the same as -1x squared, therefore a equals -1. What does b equal? What's our value of b here? 10. And then c? -23. Good. Now, we're not really going to be using c at all today, but it's good to get in the habit of anytime you have a quadratic and you're trying to figure things out about it, know what a, b, and c are equal to. So even though we're not using c today, we do want to get in the habit of writing that down. Does this graph open up or down? Down. A is negative, it opens down. And the reason why we need that is because we need to know when we make our sketch what direction to draw our parabola, whether it's a regular U or an upside down U. This one's upside down. All right, our axis of symmetry. X equals the opposite of b. So what's the opposite of 10? Opposite of b would be what? What is it? -10, yeah. So -10 divided by 2 times a is -1. 2 times -1 is -2. -10 divided by -2 is what? Just 5. Yeah, +5. So x equals 5. All right, so axis of symmetry right here. X equals 5. Which means that the x coordinate of the vertex is 5. So we're going to say 5, comma, we'll leave that blank for a second. So we need to find the y value, which means we have to plug that into this function right here. Now, when we rewrite this equation, I'm not going to write negative x squared. I'm going to write negative 1. So I'm going to say y equals negative 1 and then times, in parentheses, 5 squared. So again, always put that number in parentheses on your calculator, and then plus 10 times 5, and then minus 23. And you can just type that in exactly as you see it onto the calculator, and it will give you the answer. Or if you want to use mental math to do it, that's fine too. So 5 squared is 25 times negative 1 is negative 25. 10 times 5 is 50, and then minus 23. So that equals 2. Is that right? I'm going to double check my math real quick just to make sure. I think it's 2, but. Okay. Y equals 2. Negative 25 plus 50 is positive 25, minus 23 is 2. All right, then our sketch. So we've got our axis of symmetry is x equals 5, vertex 5, 2, and then our quick sketch. This time our axis of symmetry is in the positives, and it's positive 5. So I don't know, maybe that's about here. Again, we don't have any numbers on our number line, so we'll do a lot of estimation here today. Let's see. Oh, not here. Not here. Thank you. All right. 5, 2. So over 5 up 2, that'll be about there, I guess. And then this is going to open down. So it opens upside down. So it'll look about like that. Okay. Let's have a look then at our next problem. And once we do this next one, I'll have you work on a few on your own. We might be able to get through all of these. Let's see. So number 3, what does A equal? Problem number 3, what does A equal? 3. What does B equal? Negative 12. Good. What does C equal? 5. Are we opening up or down on this one? Opens up. Yep. A is positive, so opens up. Okay. So then we need to figure out our axis of symmetry. So that'll be x equals the opposite of b. If b is negative 12, what's the opposite of b? Just 12. Yeah. All right. So 12 divided by 2 times a. So that'd be 2 times 3, which is 6. What's 12 divided by 6? 2. So x equals 2. All right. Axis of symmetry, x equals 2. Vertex then will be 2 comma whatever the y value is. So then we're going to take our value of x, plug it into the equation, and solve for y. So y equals 3 times 2 squared minus 12 times 2, and then plus 5. So that'll be, let's see, 4, 12 minus 24 plus 5. So negative 7 for y. Y equals negative 7. So 2 negative 7 for our vertex. And our sketch. We have our axis of symmetry at positive 2. So I don't know, maybe that's about right here. And then our vertex is at 2, negative 7. So if this is 2, that would be like 2, 4, 6. So that'll be like way down here, roughly. And then it's going to open up facing upwards. So that's important because if it faced down, we'd have a problem. We wouldn't have enough room. So this one, I don't know, coming about like that. Ish, I don't know. We don't know yet. We're not being super detailed with our graphs yet. We will get there. I'm trying to think, when will we do that? Tomorrow. We're going to get a lot more detailed with our graphing tomorrow. All right. Try number 4 on your own. Take a couple minutes on that one. Work out the axis of symmetry, the vertex, and do a quick sketch of number 4. We'll check back in and see how that went. All right. Number 4, what does A equal? A equals 4, good. What does B equal? 8. What does C equal? -1. Awesome. All right. Does this one open up or down? Opens up. All right. So what's our axis of symmetry on this one? Tell me what you get. -1? Okay, let's find out. So x is equal to the opposite of b, which will be -8, divided by 2 times a, which is 4. And then 2 times 4 is 8, so -8 divided by 8 would be -1. Good. So we got -1, comma, all right. And then what would our y value be? For the vertex. Anybody have that? Not yet. All right, let's find out. So y equals 4 times -1 squared plus 8 times -1 minus 1. -1 squared is 1 times 4 is 4. 8 times -1 would be -8 and then -1. So -5. Y equals -5. Cool. So then our sketch over here. This one opens up again. We've got our axis of symmetry at -1, so maybe about right here. And then our vertex down at -5. And this one opens up, so maybe about like that. Cool. Let's move on to number 7. So we'll skip 5 and 6. Take a look at number 7. I would like you to try that one. Again, give that one a go on your own. Be careful about this one, though, because there's only 2 terms there. So you need to know which one is A, which one is B, and which one is C. And there's only going to be 2 out of those 3 on this one. There's only 2 of those that we're going to end up with on this particular one. So take a look, work out which one's A, which one's B, which one's C, which of those 2 is there, because there's only 2 of the 3. Then figure out your axis of symmetry and your vertex after that. Do a quick sketch, just like we've been doing. So a couple minutes on that, see what you come up with. All right, number 7. What does A equal? -1. Good. What about B? 4. Okay. C? C is 0. Good. There's no regular number in this one, so C is always just the regular number. We're not using C, but that's what C is equal to. It's equal to 0. All right. Does this one open up or down? Opens down. Good. A is negative, so it opens down. And so our axis of symmetry then will be x equals the opposite of b, so opposite of 4 would be -4, divided by 2 times a, so that's 2 times -1. So what is our axis of symmetry? X equals what? Yeah. Just 2, yeah. So it'll be -4 divided by -2, so x equals 2. So our vertex then, we're going to have -2, and then comma, we're going to drop in our, not -2, sorry, just 2. We're going to drop in our 2 into the formula here, or the equation. And so we're going to get -1 times 2 squared plus 4 times 2. All right. 2 squared is 4. 4 times -1 is -4. All right, so that'll be -4, and then 4 times 2 is 8. So y equals 4. The vertex will be at 2, 4. And we're going to make our sketch. And it's a positive axis of symmetry. So +2, be about right here maybe. And then 4 for our vertex. So we're going to go up there. And then this opens down. So something like this. Our sketch on number 7. We're going to do just one more. We're going to take a look at number 9, and then we're going to call it good, and you'll be able to work on your assignment for the rest of the class, which should be plenty of time to get work done today. So last one here, number 9. There's 7. Make sure you get that down if you need it. And then number 9. What's our value of A on number 9? -2. What is our value of B on number 9? 0. Good. There is no term with just regular x here, and B always goes with just the regular x. So if it's not there, that means B is 0. So what does C equal then? 8. That's the number by itself. C equals 8. Awesome. So then we're going to use our, well, we got to figure out if it opens up or down first. So is this going to open up or down? Down, because it's -A. So A is negative, so it opens down. And so they're going to have x equals the opposite of B. Well, it's just 0. Divided by 2 times A, which is -2. 0 divided by anything is what? 0. Yeah, so x equals 0. So axis of symmetry, x is equal to 0. So we got to get our vertex after that. So we'll plug in 0 into the equation and solve for y. So y equals -2 times 0 squared plus 8. So this whole thing here would just be 0 plus 8 would be 8. So y equals 8. So the vertex is at 0, 8. It opens down. So our sketch, we don't need to do a axis of symmetry on this one, the dotted line, because it's the same as the y-axis. So we'll just go, as high as we need to here. Maybe that's 8 right there. And then it opens down. So there's our sketch for that last one. All right. So that is it for our first lesson on quadratics.